5,000 liters. We've still got 5,000 liters. We've still got no salt in the tank initially, so Q of 0 equals 0. The brine is coming in at 0.2 kilograms per liter, and it's coming in at 10 liters a minute. Okay. But now it's draining at 11 liters per minute. So now it's draining at 11 liters per minute. Okay, let's see what happens to the differential equation. So we set it up. Again, dq dt is rate in minus rate out. The rate in is still the same. It's going to be what? 0.2 times 10, so it's going to be 2 kilograms per minute. What's the rate out, though? Let's think about this. What's the rate out? What is the density? What is the density? That's the key. What is the density coming out? Q over what?
5,000.
Well, not quite. Because what's going to happen if it's draining at 11 liters per minute and it's coming in at 10 liters per minute? What's going to happen to the water level in the tank over time? It's going to drop. So over time, at time t, how far has it dropped?
5,000 minus t.
5,000. It'll be at 5,000 minus t. It'll drop t liters, right? After t minutes, it will drop t liters because it's losing a liter every minute. So after t minutes, it will drop t liters. So this is going to be 5,000 minus t. Okay. So now we're in this situation where we have dq dt plus
Get out of 0.
Okay, plus we're going to have 1 over 5,000 minus t q is equal to 2. Okay, and we have to solve for q. However, is it separable? Yeah.
Wait, do you have to multiply by 11? The q over 5,000 minus t?
Because it should be multiplied the fluid rate out.
No, it's coming in at 10 and it's leaving at 11. So every minute you lose a liter. So after t minutes you lose t liters.
Yeah, so wouldn't it be like 11t then? Wouldn't it be like 11t then?
Yeah, but 10t is coming in, so you're only losing t.
11 minus 10 is 1.
Wait, you already included the fluid rate. No.
Oh, I didn't put the fluid rate. That was that's what I missed, is the 10 here. I should have put the 10 there.
For 11.
11.
Oh, 11. That's what you meant. Okay, yeah. Yeah, the 11 has to be there. Yeah. So this should be 11. Yeah. So the question is, what is this? Is it separable?
Sure.
Is it?
I don't know. I have to do the linear.
Can you get the dt on the other side can you get the q's with the dq and the t's with the dq with an addition there?
Nah.
You can change in the formula like y prime
It's not separable. It's not separable. So how do you solve this? You need another technique, and another technique is called first order linear. So first order linear. Yeah.
We talk about it in Friday.
Yeah, it's repeating what we did on Friday. It's also on the old video when they try to get it up. So first order linear, first order linear looks like this. You have like y prime, you have the derivative, and then you have like some function of x or t in this case, some function of t, and then you have y, and then you have some other function, whatever you want to call it, g of t, whatever. Okay, so this is a first order linear. Okay, and that's what we have here. We've got the derivative dq dt. We've got some function of t times q itself, and then we've got some function. This happens to be a constant, but it could be any function. Okay, so there's a trick, and the trick is to multiply both sides of this equation by e to the antiderivative of p of t dt. This is called the integrating factor.
E to the antiderivative?
E raised to the antiderivative of p of t dt. Now the reason for doing this is that when you multiply both sides of the equation by this, you get a nice reduction. You get e to the antiderivative of p of t dt y prime plus e to the antiderivative of p of t dt p of t y is equal to g of t. And what happens is that this is a product rule derivative of the integrating factor times y. In other words, I claim that this left-hand side is the derivative of e to the antiderivative p of t dt times y. And you can see this by the product rule. Because first times derivative of second plus second times the derivative of first. And the derivative of this by the chain rules is going to repeat, but then you're going to multiply by the derivative of the inner. And the derivative of the antiderivative is the p itself. And that's why it's a product rule with a chain rule on the sub-expression. Okay, so what we have now is we get the solution. We just integrate g of t. So in other words, y is going to be you integrate both sides. And so y is going to be I had to multiply over here by the integration factor. If I multiplied the whole equation, I just didn't write it over here. Okay, so y is going to be the integral of g of t times the integrating factor, all integrated dt, divided by the integrating factor itself. That's going to be the solution. So, this is first order linear. To get back to our problem, this is first order linear. So to solve this, here's what we're going to do. This is the solution. So what we're going to do is we're going to take, now the theory is based on plus. And here you have a, here you have a plus, so we're okay. If it was a minus, if this was a minus, you'd have to make this your integrating factor with the minus sign. You'd have to include it in the integrating factor because the theory is based on a plus. So if you had a minus, you'd have to have the minus in here. Okay? Yeah.
I apologize to backtrack, but can you go back to how you got the integrating factor?
Oh, it's just a trick someone thought of.
Okay.
Yeah. They just thought of this trick so that when you multiply both sides of the equation by it, the left-hand side reduces to a single derivative of a product. It's just a trick to get a solution. Yeah. So, and typically all these differential equations are like tricks people thought of. Yeah. So, what's our integrating factor? It's e to the antiderivative of 11 over 5,000 minus t dt. So we just have to do this. What is this? What's the antiderivative of this?
Negative 11 5,000 minus t.
E to the minus 11 ln 5,000 minus t. Yes. And what is that? What can we do with this minus 11? With an ln, what can you do with it? We can throw it inside as an exponent. Yeah? So we can make it e to the ln of 5,000 minus t raised to the negative 11 power. Make it this. Yeah? And then now the e and the ln are wiping out. So this is just going to be 5,000 minus t to the negative 11. So that's going to be the integrating factor. Okay? Now we can get the solution from this formula. Because the solution says that we take the integrating factor, multiply it by 2 in this case, which is the g function, and then we divide by the integrating factor. So it's telling you that the solution is going to be q is going to equal the antiderivative of 2 times 5,000 minus t to the negative 11 dt divided by itself 5,000 minus t to the minus 11. Okay, so let's see what this is. What's the antiderivative of 2 times 5,000 minus t to the negative 11? What rule are you going to use? So like you could use a u sub, right? It's a power rule with a u sub, yeah. But you could compensate. You just, what's the thing that's going to come out to the outside? What's the compensation? Yeah, the 2, but what about the minus sign? Right? Right, there's going to be a negative. Okay, so we should be getting minus 2. That's the compensation for the chain rule, and the rest is a power rule. It's going to be 5,000 minus t to the what? To the negative 10 divided by negative 10, and then these will cancel, and that'll become a 5. Okay, so, and then we'll say plus c. So that's the antiderivative, and then we still have to divide by this. Okay, so let's see what we get. We get, when you divide by this to the negative 11, it's like multiplying by it to the 11. So in other words, you're going to get 5,000 minus t to the 11th power times 5,000 minus t to the negative 10 over 5 plus c. Okay? So let's see what that is. When I multiply this together, I just get 5,000 minus t. And then when I distribute it through, I get this constant 5,000 minus t to the 11. What's that?
I'm still following up the top. Why is there -10 and 5 at the bottom?
There was a -2 here, and there was a -10. And then that became a 5.
What became a 5?
The -2 divided by -10.
Why is there
Yeah,
five?
this,
Gotcha.
okay? So I think that's okay. Does that look okay? Okay. So that should be a solution, and we just got to find out what the C is. So we said T of 0 was 0, Q of 0 was 0. So in other words, if we have 0, what are we getting? So 5,000 over 5. Let's figure out what C is. 5,000 over 5 plus C times 5,000 to the 11 is 0.
What if we call the whole C multiplied by that thing as another constant?
No, it's got a variable in it. So let's just figure out what this is. So C 5,000 to the 11 is equal to -5,000 over 5. We can get rid of that. Okay, so C is going to be -1,000 over 5,000 to the 11 power. So that's going to be C. Okay? And now how much salt is in the tank after 20 minutes? Let's figure that out. So how much salt is in the tank after 20 minutes?